What's up, y'all? This is Hussein Nasser from iGeometry, where we discuss software engineering by example. Today's topic is atomicity or atomic transactions. So, in this video, we will explain what is an atomic transaction, and we will go through an example, as we usually do on this channel, where we pick the topic and we explain it by an actual real-life example. So, let's just jump into it. So, let's start with a quick definition of an atomicity or an atomic transaction. Especially this is very critical in DBMSs or relational databases, right? So where you have a certain set of transactions and you want all these transactions to be executed all together, or none of them should be executed, right? So if any failures happen within this transaction, you want to roll back all of these edits that you made, essentially. And the reason we want that to preserve consistency, whatever that means, which is another topic, right? Consistency is like a human perceived state of your database. I want my database to be consistent. That means I want this number of rows to be equal always this number of fields, or a value of a different field. So that's in a nutshell an atomic transaction. You want a set of transactions to be executed as a unit of work, or operations to be executed as a unit of work. Today's example is actually Instagram. So let's assume Instagram, or this photo sharing app, consists of two simple tables. Obviously it's more complicated than that, but you have one table called pictures and you have another table called likes, right? So that's very simple stuff. So we have the pictures table, which has an ID, this is the primary key, and the number of likes this picture got, right? So in this case 2, and the second picture got, for example, picture 2 got 1 like, right? So if you look at the likes table, it tells you more information about how what are these likes coming from, right? So we have a picture ID and the user ID, and both those will be a composite primary key, a unique constraint index on this likes table, right? So the pictures table, we have a one primary key ID, and this is picture ID, and the user ID composes a primary key, so you cannot duplicate that. And you can see this is a consistent state, right? That's what we were talking about, where we have picture ID 1 got 2 likes in this picture, in this row, and if you look at the likes table, you have actually 2 rows. Bob and Alice liked picture 1, and picture 2 only was liked by Bob. So it is a consistent state. So that's what I mean by consistent. And we kind of contrived that, right? We designed the system to be consistent in this manner. And if this system is like that, we call it consistent, right? So we need atomic operations to happen to ensure consistency of the system. Does that make sense? Hope it does. Well, let's jump into an example. So I want to do is Alice want to like picture 2. So Alice likes picture 2. What happens behind the scenes, really, right? So a like is actually a transaction which consists of 2 SQL statements. Okay, the first one is updates the pictures table, increase the like where ID is equal to. That's exactly what it means, right? So go ahead and increase that. And then the second one, actually insert a row in the likes table where the picture ID and the name of the user that is liking this picture. Simple stuff, right? So I will execute the first statement. I'll increase that to nice, all right? So that seems to be executed successfully, right? I updated that. Be aware that this is not actually written in the database yet, right? So this is happening in a transaction, and this is we call a dirty write. It's still writing, but things can go wrong, right? We still didn't commit my edit, so it's not committed to the disk yet. So we have that. So I increase that now. Likes is 2, so go ahead and execute the second statement, which is inserting a new row, which is 2ls. That seems to go well as well, right? And the third final state is go ahead and commit. So commit that change. Now it's flushed to the disk, right? And if you look at the system, is it consistent? Looks like it, right? We have 2 likes of picture ID, and now those 2 actually correspond to 2 rows, right? So picture ID Bob and picture ID Alice. So 2, 2, that number is correct. We are consistent, all right? And let's go an example where things can go wrong, okay? And that's where an atomic transaction really is so beneficial. Okay, atomic transaction. Bob likes picture 2. So if you notice, Bob has already liked picture 2. So things can go wrong because you cannot insert this row again, right? You're gonna fail. Okay, but let's see what happens. So similar, right? So the same thing. Picture ID is the only difference to Bob, right? That's the only difference here. So let's go ahead and execute the first thing. And that seems to go well. I just increment the number of likes, right? So now I have 3, right? 3 likes. Okay, I increased that. And now I want to go ahead and insert a new row in the picture ID, which will fail because of a unique constraint. You cannot insert 2 and Bob because 2 and Bob already exist. The database will yell at you and say, hey, you cannot do that. I'm sorry. Poof, roll back. So that is what atomic transaction here. The database is responsible to have an atomicity property. And this is a key thing here, right? So if I fail, remember, I just written something here on row 3, right? I have written something here. I've changed something. So the database better go and change that back to the original state, right? Otherwise, we are not consistent. Looking at the system right now, it's not consistent. Why? Because it says here that you have 3, but looking at the likes table and we have only 2 rows. And that's the inconsistency that you don't want to. Obviously, guys, if you think about it, something like that, it's not really a big deal, right? Because of picture ID. But if you think about like a banking system and rows and actual transactions and financial things, that becomes really, really critical, right? Real life system is atomicity is very, very critical. All right, that's why a rollback, a correct rollback, will change everything back to a correct state. It says, you know what? Database says, hey, something failed happened. Something have failed. So let me just roll back everything I changed and get you back to a consistent state, whatever that means, right? Again, a consistent state is the state where you started before I started changing that thing. And if you start thinking about it, that's in a nutshell an atomic operation. And just like think about the stuff that you can do while you are in editing, right? While editing, right? While you're changing things and you're not committing things yet, a lot of people can go and jump in and start reading your stuff. So you can yield into dirty reads, which we'll explain in another video, hopefully, and a lot of other read phenomena. All right, guys, I think I'll stop here, and I'm gonna see you in the next one. If you're interested in software engineering and database stuff, consider subscribing. I have a lot of videos like that. We explain a lot of software engineering topics by example, just like that, right? And I'm gonna see you in the next one. You guys stay awesome.